and welcome to space, here from the surface of planet Mars, or at least as close as you can get to it on Earth. I'm here in the UK and in Belgium to meet up with scientists and engineers working on the ExoMars mission, the joint European and Russian effort to go to the red planet and look for life. Let's find out what's happening. Meet Bruno the Mars rover, a six-wheeled machine with a top speed of 2 centimeters per second and the ability to drive on Mars semi-autonomously. He's a testbed for Airbus engineers as they build the first rover to look for signs of life on Mars.
Bruno is pretty much the same as the ExoMars rover will look like. I mean, he's got on him all the sensors and the actuators you use to drive the rover by itself. Starting with these two cameras at the top of the mast. They allow the rover to see in 3D in much the same way we do and identify the rocks and the slopes in front of it and then analyse if any are outside of its capabilities.
This is what the rover should look like when it lands in 2021. What's unique is it can drill down 2 meters below the surface and process samples in its onboard laboratory. For the engineers, it brings huge challenges, like reinventing the wheel.
So these metallic wheels are really an important part of the locomotion system. We're not allowed to use rubber because it's an organic material, and if we're trying to detect life on Mars, we don't want to detect something we've brought with us. So instead we have to get that sort of same rubber compression, the squidginess, in a metal wheel, which is exactly what these flexible wheels do.
The actual flight model rover is being constructed in this purpose-built clean room in Stevenage near London. Here, each component and instrument arriving from science labs across Europe is sterilised and then assembled.
This small panel that you can see over there, the square shape, is where all the electronics of the service module of the ExoMars rover will be built. As you can see, everything is assembled in this room, which was designed specifically for the ExoMars mission. And if there is life on Mars, I hope we find it with this mission.
The absolute imperative not to take samples of life from Earth to Mars means great lengths have been taken to keep the rover pristine.
There's been a lot of different challenges, getting tools very clean, getting all of the ground support equipment very clean, and also this facility here is so that all the electronic engineers can work on the rover, but without having to go into that clean room facility because it's such a big deal to have to put all of the gear on to go in there.
The joint ESA-Roscosmos mission has already launched its first spacecraft to the red planet, the ExoMars Trace Gas Orbiter, which blasted off in 2016. It's been in full operation since April this year, sniffing the atmosphere for methane and imaging the surface in detail. After a series of meetings, including this one at the Belgian Science Policy Office, the team has now selected the landing site for the second ExoMars mission. They want the rover to explore a zone called Oxyaplanum, a former lake close to the equator.
Oxyaplanum is really one of the most interesting places to go with the lander to investigate, in particular with the drill cores you can take up, doing analysis of the surface material, subsurface material. In addition, it is quite a safe place to go and land because we know that the surface is safe for landing. It is located on a low level so that the spacecraft has a lot of atmosphere to go down through and slow down and has time to react and respond before it lands.
The Russian component of the mission is the landing platform, which will carry the ExoMars rover. The platform should be loaded with instruments to measure the Martian atmosphere, although time is ticking to get them ready.
No doubt, the launch in July 2020 is quite an ambitious task because, as regards the scientific equipment of the landing platform is on a particularly critical path because it began to be developed much later than the equipment on the rover.
What the mission has so far taught us is that Mars is much more diverse and dynamic than expected, as these images from the Swiss Cassis camera on the ExoMars Trace Gas Orbiter show. What's more, scientists are detecting water ice just below the surface in lots of places.
The water on Mars is, first of all, underground. We don't find any open lakes, and the water is in the frozen form, so we have ice underground. Liquid water has always been seen as a prerequisite for life. Doesn't necessarily mean that we have it there, but it is one ingredient that we would need to have life.
Our view of Mars is evolving quickly. So, do the experts think ExoMars will find signs of life, now or in the past?
Yes, naturally. I hope that ExoMars will find traces of the existence of organic compounds on the surface of Mars. And, of course, ExoMars is exactly the mission that should do this. It was designed for this.
I think we've got the best instruments that we possibly can on board to be able to detect life. The big thing is having the drill so that we can actually get to the depths that we think that life would still be both alive if it could be and recognisable even if it wasn't. That's the big thing that nobody's ever really done before.
The projected mission will see the ExoMars rover drive around 4 kilometres and drill down 2 metres below the surface at least 6 times. If it found something, what would it look like?
I think it's unlikely to be sort of little green men at this stage. It's probably going to be bacteria, because we tend to find that in the most arid locations on Earth. It's the most hardy form of life we know. So it's fairly likely that that's the sort of life we're going to find below the surface.
We should know more when the ExoMars rover platform lands in March 2021. Well, we're going to carry on with the Mars theme here at Airbus in Stevenage with the part of the show that we call Ask Space, in which we take your questions about the universe and put them to the experts. And I'm here with Manish Patel from the Open University. Manish, we've had a lot of questions about human exploration of Mars. Shokruk Yusupov asked us, when will humans reach Mars?
We've been planning to go to Mars for a long time as humans. We've been there for many years now with robotic craft. I think the time is coming for us to go there with people. And that's come about primarily because of players like SpaceX, so commercial entities entering the market who are changing the way we launch, the way we get into space and how we can get to Mars. I think within the next 20 years, or certainly within my lifetime, we'll be seeing people on Mars.
We've also had questions from people asking about how humans would actually live on Mars, whether they'd be under domes, would they live underground, should they take oxygen with them? What do you say to that?
You would probably have a dome or some kind of cabin that you'd have to stay in, like on the space station, but on the surface of Mars. That would shield you from the harmful radiation, the low pressure, you'd have a breathable atmosphere. One of the key things you'll need on Mars is obviously oxygen. If you can tap the ice that we know is present on Mars, what we can do is, ice, as you know, is formed of hydrogen and oxygen. By separating that oxygen, you can evolve that oxygen, which you can then harvest and use for breathing.
Thank you very much, Manish, for those insights. And you can send your questions about the universe using the Ask Space hashtag, and we'll try to answer them. And you can follow other space news on Euronews.com.